So for this first little bit, put your pencils down. You guys are so much more willing to do that than to pick your pencils up. I don't understand. All right, let's talk about polynomials. So what does a degree 1 polynomial look like? So it's a slanted line. Degree 0 is actually flat. But any sort of slanted line is a degree 1 polynomial. Okay? Now, this is considered a positive degree 1 polynomial. What would a negative degree 1 polynomial look like? It would go in the other direction. Okay? So what about a degree 2 polynomial? So a positive degree 2 polynomial, or parabola, quadratic, is a happy parabola. Okay? A negative degree 2 polynomial would be a sad parabola. Now, what determines if a parabola is positive or negative? A leading coefficient, the first number, the one in front of the x squared. Now, if I change it from x squared to 7x squared or 10x squared or 400x squared, what does that change? It just changes how wide that parabola is. But the only way to flip it upside down, Braden, is by making it negative. Okay? What about a degree 3 polynomial? Okay, yeah, that makes sense. So a positive one, a positive degree 3 polynomial would start where? From the negative side, and it's going to go up and change directions and come back down and change directions again. Now, what does 3 tell us about the graph? It can have 3 roots. Can it have 2? Yeah, if it went through and came down and bounced off and went back up. So technically it still has 3, but one of them happened twice. So if I were to take this graph and shift it up, does it still have 3 roots? Yes, but only 2 of them are visible because this is a double root. It's repeated. What if I went up more? Does it only have 1 root? No, it still has 3. 2 of them are imaginary. Is there any way to make a degree 3 polynomial that has 3 imaginary roots? No, imaginary roots always come in pairs. You can't just have 1. You have to have 2 or 4 or 6 or 8. Okay? And what would a negative degree 3 look like? Watch how fancy I am. Flip, up, down. Ooh. That's what a negative degree 3 looks like. And it makes sense because a positive degree 1 is going up. Right? The general trend is from down to up. Well, a positive degree 3 has the same end behavior. The left side is down and the right side is up. Okay? All right. What about a degree 4 polynomial? A W or an M. I got fired from the M&M factory. Did you hear about that? I threw away all the W's. Yeah, it was sad. I told that to my 7-year-old, and he thought it was hilarious. He still laughs. So, is it possible for a degree 4 polynomial to have 3 roots? Yeah. If it went like this, 1, 2, and then the third one would be a bounce. So it technically has 4, but it has 3 distinct roots. That third one is actually also the fourth one. Is it possible for it to hit twice? Yes. What about once? Yes. What about never? Yeah, you could do all of those. And if you were to graph x to the 4th, it actually doesn't do the W thing. It just does this. It's not a parabola. Parabolas have a very specific geometric shape. It's narrower than a parabola. Parabolas have this reflection idea that doesn't apply here. There's no focus, if you remember that from last year. All right. Also, an x to the 3rd doesn't have to have this shape to it. It can actually just come down and sort of level off and then go like that. It doesn't have to actually change directions. Whenever that happens, this is called a saddle point, and that saddle point is actually not increasing or decreasing, it's flat. So if you're driving in a car, it would be decreasing, 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 and then flat, and then decreasing, decreasing, decreasing. Does that make sense? So that is increasing never, and it's decreasing everywhere but x equals 0. Okay? And then, yes, it does have one perfectly level point, and only one. Because if you move in either direction, it becomes steeper. Okay? What about at degree 5? Help me graph a degree 5. Nice try. That is a degree 5. It could also be a degree 7 or a degree 9 or a degree 11, right? Just because it has 5 roots, does that mean it's an x to the 5th? No, it's at least x to the 5th. So a degree 5 could actually look more like a degree 3. If you graph x to the 5th, it has a saddle point at 0, just like x to the 3rd, only it's much narrower. The higher the exponent, the narrower the graph becomes. But you can always widen a graph by dividing it. So you can make an x to the 3rd look like an x to the 5th if you just multiply by the right scalar. Okay. I think we're ready to start. So take a look at this first page. So the first one says, draw an example of a degree 1 polynomial with a positive leading coefficient where the root is x equals 3. So I know it hits here. Degree 1 polynomial looks like what? Straight line. Leading coefficient is positive, which means it's slanted up. A vertical line is not a function. So there is no polynomial that represents a vertical line. There is one that represents a horizontal line, but a vertical line is not a function, and all polynomials are functions. Okay, next one, degree 2. So we have -4 and 1. Leading coefficient is positive, and there are 2 roots. So what's it going to look like? A smiley parabola. Now, my parabola is actually really wide. But any parabola that opens up and hits those 2 roots is a correct answer. Okay. What about this one? Leading coefficient negative. The roots are 2 and 2. And it's a degree 2 polynomial. Upside down, and it bounces off. Does that make sense? Okay. Now, I want to show you what happens when you have a triple root or a quadruple root or something higher. A single root is easy. It just goes right through. A double root is easy. What does it do? It just bounces off. So let's draw an example of those. So for each one of these, the only root is 2. Okay? So the only root is 2. And the word multiplicity means how many times that root happens. So multiplicity of 1 would be a polynomial that hits that root once. And the leading coefficient is positive, so what would that graph look like? It's a slanted line in which direction? Up. And any time a root happens once, you just go straight through the root. Okay, the next one. Leading coefficient is negative, and the multiplicity of that root is 2. So it's going to be upside down and bounce off. Okay? So leading coefficient is positive, and the multiplicity is 3. So leading coefficient is positive. What is the end behavior going to look like? The left side is down, and the right side is up. Now, when a root happens 3 times, it doesn't go straight through, and it doesn't bounce. It has a saddle. So we're going to get close to it and slow down and level off. And we have that little saddle point. So it still goes straight through, but it slows down on its way through, and it actually levels off and then speeds up again. That's when you have a triple, like x equals 2, x equals 2, and x equals 2. Right? If you have x equals 2, it just goes straight through. 2 and 2, it bounces off. 2, 2, and 2, it does that saddle. What about if that root has a multiplicity of 4? So what if 2 happens 4 times? Can it be a W? No, because every time, so if I had a W, don't draw that. So this has a single root, a double root, and a single root. Right, any time you have a W that misses, each one of these represents 2 imaginary roots. Yes. It looks a lot like a parabola. It doesn't have the same shape as a parabola. It doesn't have, so your satellite dish is a parabola. It's a 3-dimensional parabola, and all of that information hits the dish and reflects back, and it all reflects to that one point where the receiver is, which is actually aimed away from the satellite. The receptor is aimed in, so the stuff comes in, hits the dish, and goes back, and it all focuses on that one spot. And only an x-squared graph has that geometric property. An x to the 4th will reflect stuff, but it's not going to hit. It'll just kind of scatter it. It doesn't reflect to a single point. Okay, multiplicity of 5. Leading coefficient is negative. So it looks just like an x to the 3rd, only it's a little bit narrower. But again, you can change how narrow a graph is by dividing it by 2, or timesing it by 2. So it comes down, saddles, and then goes out like that. Okay, so how does that help us? Well, let's say, and you don't need to write this one, let's say I have x equals 1, and the leading coefficient is positive, 3, 3, negative 4, negative 4, negative 4. What does that graph look like? Well, it has 3 distinct roots. So negative 4, 1, and 3. What is the end behavior going to be? Well, it's a positive x to the 6th, 6. So it's going to be positive, positive. So I know this side is up and this side is up. Now I just need to draw the rest of the graph. When I get close to negative 4, what's going to happen? It's going to have a saddle because it's a triple root. So it comes down and levels off and then goes down. Now we have to change directions. What happens at 1? Goes straight through. And then I turn around. What happens at 3? It's a double root, so it bounces off. So that's what you're doing here. Can you take the roots and the leading coefficient and draw the example of a parabola? Or of whatever the graph is, I guess. So, let me do 3 of them with you. Three and negative 5 are my roots. Leading coefficient is negative. It's got to be an x squared. So what shape will it be? An upside down parabola. And then it asks for the equation. Now, any equation will work as long as it hits those 2 roots and it has a negative leading coefficient. Can you think of a very easy way to write an equation that will work? We know the roots. What are the factors? Well, you could make it easier. We could find the vertex and then use vertex form, but there's a much easier way. If I wanted to create factors using those 2 numbers, what would they be? X minus 3 and x plus 5. Now, I could multiply those together, But if you plug that in your calculator, it will graph a parabola that hits those 2 points. But I'm missing something. It hasn't been flipped upside down yet. So any negative number out front would work. Okay? And actually, using those values, you can create any parabola that hits those 2 points by multiplying by the correct positive or negative number. So that's good enough. List the factors and then just determine if the leading coefficient is positive or negative. Okay. So we have roots at -4, 0, and 1. What shape is this going to have? The x to the third shape. Good. And the leading coefficient is negative, which means we're going to start on the top. So start up here. What happens when I get to -4? Straight through -4. Then I need to turn around. Straight through 0 and down through 1. What would the equation be? X plus 4, x minus 1, and x, and we usually put the x's out front, and it also needs to be negative. Now, when these polynomials have lots of roots and you try to graph them, and this one might not be big enough, but if you string together enough roots and you type that in your calculator, it would look like this. Because you're multiplying 4 and -1. This one's not very big, but imagine if it was 4 times 8 times 3 times 6. It gets really big. So what you do is you just take this and times it by like 0.0003. And that will shrink it down so it looks better. Now, I'm not saying you need to do that. But if you're ever up late one Friday night with nothing to do, and you want to graph these, so if you want to bring those high points down, just start timesing it by really small decimals, and it will pull it down, and then it will create a graph that actually fits in that standard window. All right. So let's look here. Roots are 0, 0, and 2. Leading coefficient is positive. This is an x to the third. Where do we start? Start at the bottom. What happens when I get near 0? It's a double root, so it's going to bounce off, turn around, and then go straight through. And I would list this not as x times x, but x squared times x minus 2. So let's just look at one of the more difficult ones. Look at number 8. So there are 2 distinct roots, 1 and -3. What degree is this polynomial? X to the 5th. So we have 1 up and 1 downside. And the leading coefficient is negative, so where am I going to begin? Start at the top. So this side is up. As I approach -3, what's going to happen? It's going to bounce off -3. I go up, and then I need to turn around. What happens at 1? It has a saddle at 1. So it looks like this, and then continues on. And the equation is going to be x plus 3 squared and x minus 1 to the third. Nobody's paying attention? I need a negative. Good. The leading coefficient is negative. So for this one, I mean, you're multiplying 3 and 3 and the 1s. Let's just try it. So just to see what happens, let's plug this in. So negative x plus 3 to the second times x minus 1 to the third. And I'm going to graph it in the standard window. so you can't really see much. So if I go in here and I multiply it by something really small, 0.001, that might be too much. That was a little bit too much. Let's multiply by 0.1. So I'm gonna make it 1/10 as tall. There you go. So the more numbers and the bigger those numbers are, the higher and lower that graph gets, and you just have to multiply it by a smaller and smaller number. But that graph is very similar to what we just came up with. All right. Okay, get to work. Good luck.